So question 10. Two curves with equations y equals x cubed, and y equals x squared. Alright, bye-bye, Dad. Question 10. Two curves with equations y equals x cubed minus 4x squared plus 3x plus 1 and y equals x squared minus 3x plus 1 intersect as shown in the diagram, okay? And we're asked, calculate the shaded area. Okay, so this is going to be an integration question. So, what is integration? Well, basically, the shaded area is going to equal the integral of the top curve minus the bottom curve. With respect to x. So, looking at this equation, which one's the top curve, which one's the bottom curve? Well, the top curve is going to be this one here, and we can see that this is a cubic shape, so it's going to be this equation here, and the bottom curve is this quadratic shape, and that is that equation there. So we can just start right off by substituting this in, and we can see the limits are between 0 and 2. Okay, so we're going to be working out the shaded area between these two curves between 0 and 2. Okay, so this is equal to the integral between 2 and 0 of x cubed minus 4x squared plus 3x plus 1 minus x squared minus 3x plus 1. We can put this in brackets just so we can see what we're doing a bit clearer. Okay, dx. Just going to put that in brackets because this might change the sign of some of the expressions in here. Okay, so what does this become? X cubed minus 4x squared plus 3x plus 1 minus x squared plus 3x minus 1 dx, and this is all still between 2 and 0. So what happens here? Well, the ones will cancel out, and the other terms, 2 and 0, x cubed minus 4x squared minus x squared becomes minus 5x squared, and then 3x plus 3x is just going to become 6x. Okay, so now, again, with respect to x, so now this is ready to be differentiated. So you can use your square brackets. So x cubed is going to become x to the 4 over 4, and this minus 5x squared is going to minus 5x to the power of 3 over 3, and plus 6x squared over 2. This is between 2 and 0. Okay, so what happens now? Well, this can be simplified a little bit. So this is x to 4 over 4 minus 5x cubed over 3 plus 6 over 2 is just 3x squared. Boom. 2 and 0. So now we can start to substitute the values of x into this equation. So this then becomes 2 to the power of 4 over 4 minus 5 to the power of 2 to the 3 all over 3 plus 3 to the power 3 times 2 to the power of 2, and because all the components in this also have an x, and when x is equal to 0, this whole expression is just going to become 0. So 2 to the power of 4 is just the same as, you could think of it as 2 squared times 2 squared, which is 4 times 4, which is 16 over 4, minus 2 to the power of 3 is 8. So 5 times 8 over 3 plus 3 times 2 squared is 4 is 12 minus 0. So what does this then become? 16 divided by 4 is 4. 5 times 8 is 40. All over 3 and plus 12. Okay. So equals. So 4 plus 12 is 16. So 16 minus 40 over 3. Now we just need to simplify this. Times 16 by 3. 16 times 2 is 36. Plus 16 is 48. So 48 over 3 minus 40 over 3 equals 8 over 3. Right, and the shaded area equals 8 over, not over 4, over 3. Okay, and that's our final answer there. Okay, so where'd you get the marks from? Well, you get 1 mark for knowing to integrate between the appropriate limits, which would be these limits here. Then you get your 2nd mark for knowing that you need to do your upper curve minus your lower curve there. And then you get your 3rd mark for doing a correct integration. You get your 4th mark for putting in the limits, and then you get your 5th mark for calculating the correct shaded area there. 5 out of 5. If you're ever unsure, just refer to the official marking scheme as well, just because this is just my interpretation of how best to go to do it. You always want to double check it for yourself. Okay, so moving on now to part B. Okay, part B. Determine the fraction of shaded area which lies below the line y equals 1 minus x. Okay, so this line here, y equals 1 minus x, goes from there to there. And so what we need to do is calculate the shaded area in here and then compare it to the overall shaded area. And from that, we'll be able to work out what fraction it is. Okay, so it's the same as before, equals, but instead of the top line is now going to be y equals 1 minus x. So this now becomes 1 minus x squared minus 3x plus 1 dx. So 2 and 0 still. Okay, so we now just need to calculate this. So this just becomes 2, 0, 1 minus x squared minus 3, or plus 3x minus 1. So again, the minus ones, the ones are going to cancel, and this is going to come out as 2, 0 equals minus x squared plus 2x dx. Okay, so now we can integrate. So minus x squared is going to become cubed over 3, and 2x is going to become 2x squared over 2, and those 2's are just going to cancel. Okay, and this is still in our limits of 2 and 0. And now we can substitute in these limits. So equals minus 2 cubed over 8 plus 2 squared minus 0, because again all x terms, when it's 0, they're just going to be 0. So equals 2, sorry, that should be a 3, just make that clear. So this becomes minus 8 over 3 plus 4. So that just, if you can work that out, is minus 8 over 3 plus 3 times is 12 over 3. So that just equals 2 4 over 3. Now this isn't our final answer, okay, because they ask us for the fraction of the shaded area, okay? So you need to do something like this, fraction. Now you might just be able to spot it straight away, so shaded the area. So our shaded area before was 8 over 3, and our new shaded area is 4 over 3. So we can see that so I'll write it out in full so it makes more sense. Small area, or like new area, over old is equal to 4 over 3 divided by 8 over 3, which is 4 over 3 divided by 8 over 3, which is the same as saying 4 over 3 times 3 over 8. 3's cancel out. 4 over 8 is equal to 1 over 2. So you could say the fraction equals, determine the fraction of shaded area, so fraction of shaded area equals half the area. Now they don't ask for a statement, but you can put one in if you want. So here, half the area. So you'd get 1 mark for using line quadratic. Not quite sure what that means in the marking scheme, but I imagine you get 1 line for using the quadratic line, making sure you use the correct line as your lower limit here. And then the second mark you'd get for integrating correctly, which you do here. And then you get your 3rd mark for substituting in your limits, and then your 4th mark for stating a fraction. Okay, there you are.